For starters, here are the answers to the prediction questions from your notes from yesterday. So you may want to pause the video so you can check your work. Today we're going to cover these 4 examples. Number 1 and 2 are the parent functions. They're the most simple versions of the square root and the cube root functions. And then 3 and 4 are manipulating those functions somewhat. The new thing that we're going to learn today that we're going to talk about is the domain and the range. So yesterday we didn't talk about the domain and the range. Today we have to talk about that. Okay, a square root function. A square root function, I am going to make an XY table and I am going to use 0, 1, 4, and 9. The reason I'm using these numbers is that these are basically perfect squares. It's easy to take the square root of these numbers. If I were to type into the calculator the square root of x and then go to the table, first of all, notice we can't put any negative numbers in because you can't do the square root of negative numbers. But then why would we want to graph these decimals? We would want to graph these whole number pieces. So the square root of 0 is 0, the square root of 1 is 1, the square root of 4 is 2, the square root of 9 is 3. Those are the points that I'm going to use. So 0, 0, 1, 1, 4, 2, and 9, 3. The domain is always the x value. So you may want to write somewhere over here to the side, the domain is always the x's, and the range is always the y. So when we talk about domain and range, specifically for square root functions, we need to look at what x values are allowed and what x values are not allowed. So really, this point right here is the key to your domain. The x value of this point is 0. The x value of the next point is 1, and then 4, and then 9. All of those x values are 0 or larger. All of your x values are larger than or equal to 0. We can't have any negative x values. Your range is the y values, and you'll notice that the y value of this point is 0. Notice there are no y values down here. All of the y values are positive. So the range is y is greater than or equal to 0. With square root functions, you're really going to be focusing on this point and looking at, do the points go to the right and up from that, or do the points go to the right and down from that, and then determining your domain and range from there. So let's skip to number 4 and let's do another square root function. Now on your assignment, it's going to be multiple choice. They're going to give you like 4 graphs and say which of the graphs is the graph of this function. So if we look at this and realize that -1 means right 1 and +3 means up 3. That means that instead of starting at 0, 0, this is going to start at right 1 and up 3. This graph is going to start here. That might be enough to help you pick out the correct graph. Then you'd see this 2 means that it's a stretch. So it's going to be a little bit taller than a normal square root function. And you'll also notice that there's no negative, so there's no flip. So if you see a graph that looks like that, you know that that is not the correct. You can use your graphing calculator to help you. In fact, I would encourage you to use the graphing calculator on your computer to help you. You can also go to Desmos.com. That's Desmos.com. And there's a grapher, like you can say start graphing, and then you can try this there. In fact, once we're done, if I have some time in the video, I might show you how to use Desmos.com. Okay, so in the calculator, you would type in 2, second, and then your square button to get your square root. X minus 1, you want the -1 to be under the radical, then move outside of the radical to put in +3. If you have an older graphing calculator, it would give you parentheses underneath that radical, or it would do like a parentheses symbol or a square root symbol and then parentheses. You would type in that x minus 1 and then close your parentheses. That would be what's underneath the radical and then +3. Push graph. That'll show you a picture of the graph, which might help you, but then the really helpful thing is second table, and then you can look at some of the points on here. So I know the point 1, 3 is on here. I've got that on my graph. The point 2, 5, and then I think the point 5, 7. And that should give you enough to get a decent picture of that graph. Now the domain and the range. The domain and the range is going to come from this starting point. Notice on your table you've got errors up until that starting point. So I want you to think about what are the coordinates of this point. The coordinates of this point are 1, 3. The 1 is going to help you with your domain, and the 3 is going to help you with your range. My daughter wants to say hello.
Hello.
Okay, so the domain, all of the points are to the right of that starting point, so x is going to be greater than or equal to 1. And for that 3, all of the points are above, so y is greater than or equal to 3. Basically, your domain and range starts out as x greater than or equal to 0, y greater than or equal to 0, and then because we moved right 1, it shifted that domain right 1. We moved up 3, it shifted the range up 3. Cube root functions are a little bit different, and actually you're going to prefer cube root functions. If I graph math button, I need option 4, the third root of x. It's that funky S-shaped graph. If I pull up some points, on the negative side, I want the point -8, -2. I'm actually going to write these down. And then I've got the point -1, -1, 0, 0, 1, 1. And you might notice that this is kind of symmetrical in a rotational way. So 8, 2 is my other point. Now, if you look at your perfects chart, 8 and 1 are perfect cubes. So it makes sense that we use those numbers when we are graphing the cube root, because we want to do the cube root of perfect cubes. Here's the awesome thing. Because, oh, she dropped her stuffed animal. Because the graph extends to the left and to the right, your domain is all real numbers. And because the graph stretches up and down on both sides, your range is all real numbers. So the nice thing about cube root functions is that you don't really have to think about the domain and the range. You can just write all real numbers, all real numbers. Okay, this next one, number 3. The +1 tells us that this graph is going to move left 1. The -2 tells us it's going to move down 2. So instead of that inflection point being at 0, 0, it's going to be left 1 and down 2. So right now, you'd probably be able to tell that the graph is going to look something like that. If you have one option that looks like that, you're good. You've found your graph. So really, in this section, the homework is looking at identifying the graph based on what you know from the equation. You'll also notice that there's no stretch. So if, I can't even write today. So if one of them or two of them look extra tall, you know that that's not going to be the correct answer. There's also no flip, which means that the right side's going to go up, the left side's going to curve down and to the left. Now, if we do want to get actual points for this, we would do math button, the third root of x plus 1, get out of the radical, -2. There's what it looks like on the graph. If we go into the table, I've got the point 0, -1, that's the one I already have graphed. I see the point 7, 0. I probably want some points down here. Oh, -1, -2. Oh, 0, -1 I didn't have. -2, -3. And then if I keep going, I know there's one more up here. -9, -4. So there's the actual graph.
Mom, where's Sally?
Sally's in her kennel, sweetie. The domain is all real numbers, and the range is all real numbers. Now I did want to show you some of these on Desmos, so let me pull up Desmos. When you get to Desmos, you click the graphing calculator up at the top. And then you have a graph on the right and you have a place to type in the left. So here I just have to remember what the functions are. But I thought there was a way to pull up a keyboard. Oh, nope, don't want that. See, I don't use Desmos very frequently, so I don't always remember my features here. Okay, my recording features, we're covering it up. Down in the left corner, there's a Show Keypad button, and this gives you a lot of features here. So if you want to do the square root, you do the square root, and actually you need to type in like y equals the square root of x minus 1, move outside of the radical, plus 5. There's the graph of y equals the square root of x minus 1 plus 5, which isn't exactly what we had in our notes, but whatever. What I don't see here is the cube root, but I think there's a way, and you can always Google like how to graph cube root with Desmos, and it would probably tell you. But y equals let me see if I can figure it out. Okay, I just figured out I had to Google it. So y equals, you click on this functions and then misc up here, and then there is a cube root, or there's an nth root. So then you can type in that this is a third root of x plus 5 minus 1. So there's a graph there. So you can get to all of this in Desmos if that is the graph you prefer. And then sometimes if you click, I don't know if you saw that, if you click this little wheel, this edit list settings wheel, for each of these functions that we have entered, you can convert to table, and then it will show you points. The only thing that's not great about this is that you, oh, hold on. My daughter and her iPad. The only kind of not great thing about Desmos is that you can't just scroll up and scroll down in the table to find points, which kind of stinks. But you could look at this graph and see like, hey, an x value of -4, I think there's a good number. So if I type in -4, there's a good point. So you can look at the graph and find some points, or you can convert it to the table. All right, so your assignment is in Big Ideas Math, and it is going to be selecting the graph that matches the function and also selecting the domain and the range for each graph. So make sure you're looking carefully at whether you're dealing with a square root function or a cube root function. Square roots, you have to think about the domain and the range. Cube root functions, all real numbers, all real numbers. Good luck. Let me know if you need any help with anything.